Amy has a 10-year mortgage for $92,000 at an annual rate of 5%. Find her monthly payment using the table below. This table gives us the monthly payment on a $1,000 loan. In other words, if you just borrowed $1,000, you would use this loan table to figure out what your monthly payment would be. In this particular problem, we know it's a 10-year mortgage, so you're going to be using the column for 10 years. We also know that it's a rate of 5%, so we'll be using the row that has 5%. So the number we're interested in is this $10.61. So if Amy had only borrowed $1,000, her monthly payment would be $10.61 per month. But we know she borrowed more than that, so we have to take that into account. But she actually borrowed $92,000, so we need to know how many thousands did she borrow. In other words, how many $1,000 loans did she take out? Borrowing $92,000 is like borrowing $1,000 92 times. In other words, it's as if she took out 92 loans that were worth $1,000 each. So to calculate the actual payment, you first have to divide the amount of the mortgage by 1,000, and that'll tell us how many $1,000 loans were taken out. So now that we know that there were 92 loans taken out of $1,000 each, or at least that taking a $92,000 loan is equivalent to that, we know that all we need to do is take 92 times the monthly payment, which was $10.61. So if she's taking out 92 $1,000 loans, then she's got to pay back each month $10.61 92 times, and that comes out to $976.12. So if Amy borrowed $92,000 at 5% for 10 years, she would have to pay back each month $976.12. Now let's make a little adjustment to this problem and ask another question, but we need to remember that number from the previous calculation, that Amy right now has a monthly payment of $976.12. But they want us to take it further. They want us to complete this amortization schedule very similar to what we did in the previous problem. And again, they want us to round our answers to the nearest cent. So we need to look at this and fill out the information that's is missing. You notice that they've got a balance of $92,000 already started. That's because it's a $92,000 loan. But we've got to do the rest of it for the first 3 months. So let's get started. They told us, or we calculated, that the monthly payment was $976.12. And the monthly payment never changes. So that $976.12 goes all the way down. Now we're going to find the amount of interest paid. We've gone through this before, but remember, every row in that table represents a month. So we've got to change that annual interest rate of 5% to a monthly rate, and we know how to do that. We take the annual rate, which is little r, and divide by m, which is the number of compounding periods per year. When it's monthly payments, m is 12. So we take 5%, which is 0.05, divide by 12, and we end up with, well, 0.05 divided by 12 equals, we end up with 4.1666667 to the minus 03. And remember that negative exponent tells us that the calculator is displaying this in its version of scientific notation. And what that really means is you take the decimal point where it is and you move it to the left 3 units, and you go 1, 2, 3, and there you get your monthly interest rate. Let's push that off to the side so we can work with it. Once you get the monthly interest rate, all you have to do is take the previous month's balance and multiply it by little I. So the balance you owed in the previous month is the principal for the next month's loan, just like in the previous problem. So we've got a $92,000 previous balance multiplied by little I that we just calculated, and if you do that, you'll end up with 383.1 with 3 repeating. We want to round that to the nearest cent, and that gives us $383.33. So for the first month, the monthly payment, in fact all the monthly payments are $976.12, but for the first month the interest paid was $383.33. The amount paid on principal is just the difference between the monthly payment and the interest paid. So if you do that subtraction, you'll get the amount paid on principal. The monthly payment was $976.12. The interest paid was $383.33. If you subtract, you get $592.79. So that's the amount paid on principal. The balance at the end of month 1 is based on the previous month's balance and the amount paid on principal. The interest is sort of the bank's profit, so that doesn't really reduce your loan balance. Only thing that reduces the loan balance is the amount paid on principal. So the new balance is the previous month's balance minus how much you paid on principal. So if you take those two numbers and subtract, you end up with $91,407.21. So that's the balance owed at the end of month 1. Now we proceed to month 2. But it's the same process. We want to find the interest paid. We already found that the interest rate per period is 0.00416 repeating. So all we have to do is multiply the prior month's balance, which is $91,407.21, by that interest rate per period, which we had calculated earlier. If you do that multiplication, you'll end up with 380.8633141. And of course, as before, we're rounding our answers to the nearest cent. So that becomes $380.86. Now let's do the amount paid on principal. That's just the difference between the monthly payment and the interest paid. Do that subtraction, and you end up with $595.26. And that's the amount paid on principal. Notice that the interest paid and the paid on principal amount always add up to the monthly payment. Also keep in mind that as the months go along, the interest paid is going down and the amount paid on principal is going up. Because you're owing less every month, you have to pay less interest every month, and more of the money you pay for your monthly payment goes to the principal. Okay, now the final balance at the end of month 2, just like before, is nothing more than the previous month's balance reduced by how much you paid on principal that month. So that would be $91,407.21 minus $595.26, and that comes out to be $90,811.95. Now we want to do it for month 3. But actually, I'm going to stop here. You need practice to see if you can finish this out. So I would say pause the video right here and finish out that line for month 3, and I'll pop up the answers in a second. But pause the video right now, finish those last three values, and compare them to what I've got. So for month 3, the amount of interest paid was $378.38. The amount paid on principal was $597.74, leaving a balance at the end of 3 months of $90,214.21. If you didn't get those last 3 values, go back and check your work again, and if need be, go back and watch some of the earlier part of the video to make sure you understand how those calculations are done. The problem that I actually want to solve here is based off of a problem that I worked earlier, so I want to show the final result of that earlier problem so I can move forward from that one. But in the previous problem, Amy had a 10-year mortgage for $92,000 at an annual rate of 5%, and in that video we completed this amortization schedule for the first 3 months for her $92,000 loan. So I want to pick up from there because the problem I really want to work takes off from that point. And what it says is, what if Amy decided to pay an extra $150 a month to pay off her loan? It was a 10-year, $92,000 mortgage at 5%, remember. And we also calculated in that earlier problem a monthly payment of $976.12. If you look back at that previous problem, the monthly payment that we had calculated was $976.12. So anyway, back to the problem we want to actually work. That's the setup. We want Amy to pay a little more every month to pay this thing off a little faster. So if her old monthly payment was $976.12 and she's going to pay an extra $150 a month, then the thing to remember is the only difference between this problem and the original problem is that her monthly payment is going to go up by $150. So if you add $150 to $976.12, you get $1,126.12. So that becomes her monthly payment. Otherwise, the calculations are going to be exactly as in the previous problem. Okay, and we also know the interest rate per month that we had already calculated earlier, and since the interest rate does not change, this number is still valid. So let's go forward. We know that the amount of interest paid, we did this quite extensively in the other video. The interest paid is simply the amount of the previous month's balance, which in this case is $92,000, times the interest rate per period. So the balance in the previous month becomes the principal for the next month. So the previous month's balance times the interest rate per period will give you the amount of interest paid for a month. So for month 1, it'd be 92,000 times 0.0041666667, and that comes out to 383.3 repeating. We want to round that to the nearest cent, so that'd be 383.33, $383.33. Okay. Continuing, the amount paid on principal is just the interest paid taken away from the monthly payment. So if you take $1126.12 and subtract $383.33, you end up with $742.79, and that goes to the amount paid on principal. If you go back and look at the previous problem, notice that the steps are exactly the same. The monthly payment went up, and that's affecting some of these numbers, but otherwise the process is exactly the same. So finally, after the end of month 1, the balance is based on the prior month's balance adjusted by how much the person paid on principal. So Amy paid from that $92,000 she owed in the beginning, she paid off $742.79 of that. So if you subtract those two numbers, you end up with a new balance of $91,257.21. So now Amy doesn't owe quite as much after month 1. Move to month 2, repeat the exact same process. The amount of interest paid is simply the previous month's balance, which is now $91,257.21, multiplied by the interest rate per period, which we calculated some time ago. Multiplying those two numbers together, you get 380.2383142. Rounding it to the nearest cent, you get $380.24. The amount paid on principal, we know now, is simply the difference between the monthly payment and the interest paid. Subtracting, that gives us $745.88, and that goes in the position for the amount paid on principal. And finally, the balance after end of month 2 is simply the previous month's balance minus the amount paid on principal. So that's $91,257.21 minus $745.88. Do that subtraction, you get $90,511.33. That goes as the balance at the end of month 2. Moving to month 3, you repeat exactly the same process, but again, as I did in the previous problem, I'd like for you to do month 3 yourself. If you followed through what we did, you should be able to knock out those last 3 values very easily. So pause the video now, finish the 3 values missing in month 3, and then start it back, and I'll put in the results and you can check your work. So the interest paid is $377.13. The amount paid on principal is $748.99. And at the end of 3 months, Amy owes $89,762.34. If you went back and looked at the previous problem, you'd notice that the balance is going down faster because she's paying more. If you missed any of those, go back and recheck your work, and if necessary, rewatch this video and determine what you were doing wrong.